Hello, this is Mrs. Myers, and today we are going to learn Lesson 7.2 about similar polygons. Now we've talked a little bit about ratios and proportions, and those are going to help us with similar polygons. Similar polygons have the same exact shape, but not necessarily the same size. The symbol for similar is a squiggle like this. Okay, now remember, congruence is an equal sign with a squiggle, but this is just similar. So the definition of similar polygons says that corresponding angles are congruent, so the angles are the same exact size in the two shapes, but the lengths of the sides, this time instead of congruent, we're going to say the corresponding side lengths are proportional. Very important to remember that the angles are congruent, but the sides are proportional. Okay, so how is this different from two polygons that are congruent? Well, if you remember, two polygons that are congruent, we would have angles congruent and sides congruent. Here we have angles congruent and sides proportional. So that's a very important difference. Look at this diagram. This says quadrilateral, happens to be a trapezoid, ABCD is similar to, that squiggle means is similar to GHIJ. The correspondence of the similarity statement has the same quality as the correspondence of a congruent statement. The similarity statement, remember we used to say with the congruent statements, order matters, right? We have to line up, match up the corresponding parts in the similarity statement, just like we did with the congruent statement. So A corresponds with G. So this angle A corresponds with G. And B corresponds with H. Okay, and C goes with I, and D goes with J. Okay, so you have to have the order in the right places when you're writing your similarity statement. So based on the definition up here, angles are congruent, so A is congruent to G, B is congruent to H, because those are the corresponding angles. But this is a big extended proportion or extended ratio that shows us all of the sides that correspond to each other. Now, if you look, AB corresponds with GH. And you can see in the diagram that that makes sense. BC goes with HI. Okay? And CD goes with IJ. And then AD goes with GJ. So this is an extended ratio showing that all of these things are in proportion with each other. And we'll talk a little bit more about what that means in proportion with each other. But that everything is lined up by correspondence. So this says when three or more ratios are equal, you can write an extended ratio, which is what we have here. And let's look down below here. When two polygons are similar, we can write a similarity statement in which corresponding vertices must be written in correct order. So this is what we were just talking about. Corresponding parts are in the right order. So if we look at question number 1 here, if they have already given us this similarity statement, then we can assume that it's written in the correct order. So M must correspond with S because they're both in the first position there. So on our diagram, M corresponds with S. Since the definition says angles in similar polygons are congruent, then we know M is congruent to S. So what are the pairs of congruent angles? We're going to say angle M congruent to angle S. N goes with R, right? So angle N is congruent to angle R. And the last one, P and T. Okay, so those are the congruent angles. Now, we could mark them on our diagram. Okay, what is the extended proportion for the ratios of the corresponding sides? Well, we're going to have to take MN to SR. MN is to SR as NP is to RT as, now we'll do first and last, MP is to ST. Now, just like we talked about with ratios and proportions before, you want to make sure the tops all kind of have something in common. So we used MN, NP, MP. All of those are from the first triangle, MNP, right? And then all of the bottoms are going to be from the other triangle, SRT. So the tops have to relate to each other, the bottoms have to relate to each other. Okay. So you guys try this one on your own, and then pause the video, try it on your own, and turn it back on to check your answers. Okay, so you should have these correspondences here. D is to H, E is to J, everything in order. Check your answers. And this is your extended proportion. Okay, the scale factor of certain ratios of the sides. The scale factor of the similar polygons is the ratio of the linear measurements of two figures. So we could take this extended ratio really and replace it with numbers if we know the lengths of the sides. So if you take this example here, triangle ABC is similar to triangle XYZ. So A corresponds with X, B corresponds with Y, and C corresponds with Z. So if we take side AB, it corresponds with side XY. So AB is to XY as, now we could replace that with the length of the side. So AB is 15, XY is 6, so we could write a ratio 15 to 6. Now that simplifies, if we divide top and bottom by 3, it simplifies to 5/2. Then we can check the next corresponding pair of sides. BC corresponds with YZ. So BC to YZ. BC is 20, YZ is 8. This again can simplify. Divide top and bottom by 4. Again, you get 5/2. The last one you would do, we did AB, BC, now we need to do AC. So AC is to XZ, AC is 25, XZ is 10. Again, this simplifies to 5/2. So we say that the scale factor of these two triangles is 5/2. Now the thing is, if you have two similar figures, then when you do these scale factors for each of the corresponding sides, they all should come out exactly the same. If they don't come out exactly the same, that's an indication that the shapes are not similar. So that's what it means to be proportional. Sides are proportional. That's what makes them similar. Similar figures. Oops. Okay, so number 5 here says write a similarity statement, then find the scale factor. So the similarity statement, we have to figure out what matches up with what. We're going to go shortest side to shortest side. They don't have them drawn nicely in the shape, facing the same direction this time, but we should still be able to figure it out. Shortest side to shortest side. Medium side goes with medium side, and longest side goes with longest side. So the similarity statement, if we use ABC here, ABC is, similar to, not congruent, is similar to triangle. Well, A corresponds with what letter over here? Looks like A is between my blue and my green, so D is between my blue and my green. So D is going to be first. B goes with E, and C goes with F. Now, what is the scale factor? We would say, let's say short to short, right? So 8 to 10 equals 4/5. What if we do green to green? 12 to 15. Again, 4/5, divide top and bottom by 3. And let's do red to red. 16 to 20. Again, 4/5, divide top and bottom by 4. So scale factor is 4/5. Okay. Are the polygons similar? If they are, write a similarity statement and give the scale factor. So here you need to make sure you are putting corresponding parts in the right order. So here's a little hint here. Remember to do short to short. Okay, and long side to long side. So I'm going to let you guys try that one on your own, and part B as well, and then pause the video, turn it back on to check your answer. Okay, so part A came out not similar. Remember to do short to short and long to long. 10 is to 15, and 20 is to 15. Do not come out to the same ratio. But part B came out that they are similar. We have 3 sides that are all 18, and they match up with the 3 sides that are all 9. So we checked that. 18 to 9 is 2 to 1. And then you can check the sides that are 12, and they match up with the sides that are 12 over here, and 12 to 6 is also 2 to 1. So it's they are similar, same scale factor. Similarity statement might be different than what you might have thought, because one goes in alphabetical order. If we start at A, B, C, D, E, we end at the point between the 12s, right? We have to start over here at the S then, and go S, R, V, U, T. And so that, look carefully, make sure you have that in the right order. Okay, now applying these, we can find missing side lengths, setting up proportions here. So we can have, if we know these are similar, they tell us that they are. So now we're not checking if they are, they tell us that they are. So the top of this trapezoid would match up with 15, and this side here is what we're looking for. That's like our X. They give us the side of the bigger trapezoid. So we need to set up a proportion now with a missing part. 12 is to 15 as X is to 25. So here, remember, the tops relate to each other because they're both from the same trapezoid. The bottoms relate to each other because they're from the same trapezoid, the other trapezoid, right? These relate because they're both tops, and these relate because they're both sides, right? So make sure you're setting a proportion in the right way. Take away all those things, and we're going to solve this. So remember that you can always simplify a fraction first if it helps you to do the math. Or you could just straight multiply. If you straight multiply, you're going to get 15x equals 12 times 25. If you simplify first, you could make 12 fifteenths, divide top and bottom by 3 and get 4 fifths. Then you're going to get 5x equals 100, which is a little bit easier to do without a calculator, but they both should come out to x is 25. Oops. Well, that can't be right. Okay, silly me. 100 divided by 5 is not 25. 100 divided by 5 is 20. Silly, silly, silly. Okay, so that should be 20. The other ones you should be able to do on your own. Ooh, this one has an x minus 2. Don't forget, with a proportion with an x minus 2, think of it as being in parentheses. So when you cross multiply, you're going to have to distribute. Okay, I'm going to let you try some of these on your own. So try 8 and 9 on your own. We'll cover them in class tomorrow. Number 10 we're going to do in class, but turn the page and let's look at a little bit about scale drawings, because when we do proportions, it's going to help us with scale drawings. The length of the bridge span is 6.4. In this drawing, okay, they're saying in this drawing, from here to here, use a different color, from here to here is 6.4 centimeters. Now they give us this hint here. The scale is 1 centimeter. Every centimeter on here is equal to 200 meters in real life on the real bridge. Okay, 200 meters. So we are just going to figure out what is the actual length of this span on the real bridge. So we have to set up a proportion. Start with your scale. 1 is to 200. Now remember to think about your units. 1 centimeter is to 200 meters. And they're talking about the drawing here. 1 centimeter on the drawing equals 200 meters of actual. So what we want to do is write a proportion using the fact that on this drawing it's 6.4 centimeters. So 6.4 is going to go here because centimeters matches up with my centimeters here, right? And we're talking about the drawing. So 6.4 goes on the top. We're looking for the actual bridge that would match this drawing. So x is going to go on the bottom. Then we're going to cross multiply. We get x equals 6.4 times 200. I'm going to let you figure out that answer on your own. And then try number 12 on your own as well. Okay? Remember to use your scale first. 1 is to 20, and think about inches to miles. And then on the map, Ella must drive 4.25 inches. So make sure you are setting up your proportion so that that corresponds. Okay, so you don't need to do this homework here. That is something we'll get to another day. But before class tomorrow, I'd like you to do number 12. And remember, this page before, I'd like you to do number 8 and number 9. Okay, so make sure you have those done before class tomorrow. Quick recap. Similar polygons have angles that are congruent and sides that are proportional, meaning you can set up a true proportion of all of their sides. Okay, thanks.